sign up tag. So if you haven't already seen it, I'd highly recommend you scan that or go to the website and sign up for the mobile developer community. So this is a mechanism for Microsoft to basically contact you in terms of Windows Phone developments. And it also gives you a complimentary token that you can use to sign up to the Windows Phone Marketplace. Okay, so really good if you want to get out there and start publishing applications, save you $120 odd in terms of the sign up for the program. Let's give a moment or two for Brian, who I'm sure would have caught that image before, to capture that. I'll have the tag at the end of the session as well, so if you haven't already got it. For those who don't know me, my name's Nick Randolph. I run a company called Built to Roam, pretty much exclusively doing Windows Phone applications and services for people. One of the things we consistently do is we actually integrate with a lot of back-end services. And for those organizations who don't have existing back-end services, we end up going to the cloud and actually building stuff across Windows Azure to actually support those organizations in terms of their phone application. Because one of the aspects when you're building a phone application is you want it to be more than just about what's on the phone. You know, whether that be integrating with some back-end services to provide a backup facility, or whether you want to actually integrate with some offline services. Okay. So the agenda for today, we're going to look at some of what I classify as just lessons learned from the phone space and from the cloud space, and why those are significant in terms of how we structure applications that are going to work on the phone and connect to the cloud. We'll look at some of the different ways we can connect through to different data services. And actually what we'll do is, rather than me stepping through numerous slides, I'll actually jump in and do some coding. Now, I apologize. This is not a 200 session. It's probably more like a 300 session. So if you're code adverse, I do apologize, because there's going to be quite a bit of it. And then we'll look at how we can make use of push notifications, and I'll cover off the Windows Azure Toolkit for Windows Phone, iOS, and Android at the end, okay? Let's start with mobile. Okay, so the thing about mobile is it doesn't necessarily equate to being connected. Okay, you can have your phone, you could be offline for whatever reason. Okay, it may be that you've turned your phone into flight mode. Okay, it may be that you just happen to be in Central Australia. Okay, look at the coverage map. There's no coverage in there. Okay, or very minimal, especially if you're on any network other than Telstra. Okay, so that's something to bear in mind. No matter how good our coverage gets, chances are that in a plane or in a lift, our coverage is going to be somewhat hampered by the fact that we're in a Faraday cage, okay? They can do everything they want to try and make that better. They can provide internal Wi-Fi within the flight and provide you the ability to make calls and stuff like that. But it's always going to be a variable connectivity, okay? And even scenarios like tunnels, okay? Not every single tunnel is going to have mobile coverage, okay? So there are going to be times when you are going to be disconnected. As much as Google wants to think that the whole world is going to be connected for the rest of eternity, there are going to be scenarios always, even if it's out of space, where you're not connected, okay? The other lessons to be learned are on the cloud side, okay? Now, interestingly, this year alone, we've seen both Amazon and Microsoft being taken down at certain points, whether it be for maintenance or whether it be for an unexpected reason in terms of Amazon's case. The reality is that the cloud does not necessarily equate to always being available, okay? Interestingly, a lot of the rhetoric that comes around the cloud is high availability, it's always there, it's always on, you know, and yeah, to a large percentage of the time it is, okay? If you're a small and medium company, you're not going to go out and invest in 2 web roles and 2 worker roles just so that you've got higher availability on your website. Okay, the reality is that one web role, one worker role is going to be up there 99.9% of the time anyhow. Okay, and for the 0.1% of the time, you should be building your application so it doesn't care whether the service is there anyhow. Okay, and that's the lesson to be learned here. Is if you're building, particularly if you're building phone plus cloud, build your application in a way that doesn't care if the cloud's there or not. Okay, so you're caching stuff locally. Now, there are going to be times when you want to make sure that the cloud's there. So, for example, in the scenario that we're going to do, we're going to be uploading an image to the cloud. Now, clearly, if the cloud's not available, I'm not going to be able to upload the image. But you'll need to think about how you can potentially cache that image locally, and then when the cloud is available, upload it, okay? And similarly, if you're going to the cloud and downloading a whole bunch of data, you want to think about how you're going to cache it locally, whether it be off to a SQL database or just to a file system, so that the next time the user comes in there, it doesn't have to download from the cloud again. So there's not that continual reliance on the cloud being there. So some other challenges that are specific to mobile, okay? And these are predominantly around the latency involved with your application on the phone, okay? In most scenarios, if you're building a desktop application, chances are the user has got a very high bandwidth connection to their desktop, okay? Now, whether it be you know, an ADSL connection or a fiber connection, the reality is that it's significantly quicker than the mobile networks, okay? Even a mobile phone running on a 3G network, if you look at the additional points that it's got to hop over, your phone goes off to the nearest tower, the tower goes to the mobile infrastructure goes to the web. Now you can have a 3G connection back to the mobile tower, that's not a problem, but the fact that it's got to go those extra hops and then it's got to go off to the US for a lot of cases, you know, to serve up data, and then it's got to come back through those routes, means that you've got a significantly longer latency than if you were just on a backbone connection straight to the internet, okay? You've got other issues around bandwidth caps, okay? So your users may decide, okay, well, I've only got 20 megs this month left on my quota, your application doesn't get to play, okay? So that's something to bear in mind, okay? And again, that comes down to building your application in a way that you can go and get data, potentially if they're on a high bandwidth connection, like they're plugged into the Wi-Fi network at home, or they're on connected to the laptop, and then cache that so that when they're running on a 3G connection or a low bandwidth connection, then you're not continually polling out to the web. And definitely some of the new stuff around Windows Phone Mango with being able to offload some uploads and downloads into the background will mean that you can say, okay, we'll only do this download when I'm on a high availability network. Okay, so that's some really nice stuff. And that's actually supported across a number of different platforms as well. The other thing is network congestion. If you actually go through central CBD in Sydney, and I think Melbourne's got the same problem, there are pockets there where you do not get coverage. Okay, and it's actually got nothing to do with coverage. It's what more to do with the fact that that particular high-rise that you're standing under has got 50,000 employees in it, okay? And they're all using a mobile phone at the same time, okay? So network congestion is a major problem. And in fact, particularly Sydney is actually getting to the point where, because everyone's moving to doing video online and streaming and all sorts of funky stuff that we can now do with our phone, the congestion's just going through the roof, and basically the networks are bottoming out. So again, that's an important consideration if you're building your application as to how you're going to take it or handle that scenario. So there's some big players in the market. These are just some of the rules that, well, what these guys have done to try and make sure that their mobile scenario or their mobile store is particularly efficient. One of the major points that happens when you get a large number of users on a platform is concurrent access to a data store. Okay, so the first rule that they look at doing is they do have databases, but they're not directly interfaced by the phone. Okay, so firstly, we never write directly to you don't write SQL calls from your phone to the database, right? But more specifically, we don't go back directly to a web service that then does the database call to us. That's almost the same as connecting directly to the database, okay? It's big no-no if you're talking about mobile applications, okay? The reason being is that bottleneck, i.e. the database, ends up holding back all of your mobile traffic, okay? So they do use databases, but they try and put them on the very back end and then try and optimize their site so that they very rarely touch the databases. They scale it out horizontally, so they have thousands of servers, typically on very commodity-based hardware. It's not your average mom and dad PC. It's server-grade hardware, but they're not, the beast machines. Okay, they're basically servers that they can buy in units of thousands or potentially tens of thousands. Okay, so they buy them in big container loads. If one of the two of them goes out, they don't even look at them. They just go, "Oh, we'll move on to the next one." In fact, I think the HP server farms that you can buy as basically a container, they don't even come and look at them unless 50 of the units inside of it are out, okay? That's a lot of dead machines, okay? They do load balancing at every tier. They've got a whole bunch of in-memory distributed caches, and they use some very, very funky algorithms for doing big data type problems, okay? The question is, how are you going to scale on Windows Azure? So again, these are just some of the rules that you can think about in terms of scaling your application out, okay? So obviously, Windows Azure is particularly good in terms of managing instances and roles. So the first thing that you need to make a decision with your application in the cloud side is, what type of roles am I going to be using? Am I going to be using a web role, i.e. for web services or websites? Okay, so inbound HTTP traffic. Or am I going to be using worker roles? Okay, so worker roles are typically, I would say that they're similar to Windows servers in concept. Okay, so they sit there, they basically have a single run method, then they continually iterate. Okay. Particularly good for grabbing content off a queue, processing it, maybe writing stuff back to a queue, writing stuff out to blob storage, or even sending messages out to your mobile device, okay? The important thing about that, though, is that we can scale at both levels. Okay, we can scale out our web requests. Okay, so web roles. Okay, so if we're getting like hundreds and thousands of users at a particular point, we can scale at that point. They might all be just putting messages onto an individual queue. Now, it may be that they put in very small messages that a single worker role can sit there and just iterate through over time, and that we don't have any time dependency there. So we can just have the worker role sitting there going, yep, that's cool, one worker role, 1,000 web roles, okay? Alternatively, it may be that your inputs are relatively large chunks of work. So for example, if we're rendering images or movies and things like that, we might have a single web role that takes an input from, it could even be from a mobile device, but then spawns off thousands of worker roles or tasks to be done that could be done in parallel and maybe aggregated at the end, okay? So again, we can scale independently at those two different levels. SQL Azure is great as a back-end database. It is useless as a database that is serving up data on an ongoing basis. So I would not use it as a database that you connect directly to from your phone to your service direct to your database. Okay. Reason being, it is slow. Okay. But the reason being is that SQL Azure is essentially SQL Server running in high availability mode. That means there are 3 nodes. Okay. You write a request to one of them. It has to be propagated to those other 2 nodes before you get a response saying, yes, I've completed that transaction. That makes it incredibly, incredibly slow, despite the fact that they've improved the performance of it. Okay. The other thing about SQL Azure is that the connectivity is somewhat suspect because it's going through a whole bunch of load balancers. Okay, so if you hold the connection open, so you start a transaction and you go on for like a minute or 2 in terms of doing a transaction, you may have to retry that transaction because it may get terminated. The load balancer will go, oh, you've been sitting idle for more than 10 seconds. No, I think it's about 60 seconds. I'm going to cut your connection, and you're going to have to restart that. Okay, so because of the way that everything's done through a whole bunch of load balancers at different tiers, you may run into connectivity issues with SQL Azure. Okay, so there is some additional retry logic, and it's published on the SQL Azure blog about how you can structure your code to take advantage of that if you're going down that path. So, okay, but we still want to make use of SQL Azure because it is our relational backend. Okay, that's how we store our relational database. It's really easy because you're spending like $10 a month to have a whole data, a gigabytes worth of relational storage in the cloud. Okay, so it's quite a good way of storing relational data. It's just useless as a way to connect straight through to it. So what do? Okay, well, we use our worker roles on both the input and the output. Okay, on the inbound stuff, we basically take content from our web role and we put it onto a queue. Worker role sits there, grabs stuff off the queue and puts it into the database. Okay. On the output, once we've made those changes to the database, of course, any data that the clients have got is now stale, so we actually want to use another worker role, could be the same worker role, to basically take the data and pre-cache it and pre-push it out to our, in this case, either table storage or blob storage, so that when we make a web request to go and get that data, instead of going to our database, we just go, okay, well, it's here in blob storage, or it's here in table storage. Okay, if those are empty, then we can go to our database and actually pull out those records. Okay, so we're trying to cache at as many levels as possible. And in actual fact, one of the new things that they're introducing is App Fabric caching. So essentially, this is caching at the very, very edge tier. Okay, so you're basically going pre-cache, or you go and get data, and then you cache it at that end tier. Now, this unfortunately isn't as easy as just switching it on. There is some code involved with it, and it is actually relatively expensive at the moment to do. But if you're looking for that extra little bit of performance, definitely highly recommend using that. The other thing to recognize is that sometimes your WCF services are not necessarily the best way to go because they use fairly verbose SOAP messages, okay? And particularly, you may be consuming an OData feed, okay? Again, it's not SOAP, but it is actually fairly verbose XML. So you may want to consider actually switching across and using a JSON service, okay? Flipping across to using that will mean at least the content that's coming down is relatively small. From a mobile perspective, the other thing you may want to consider is actually using compression there. So iOS 7 actually supports compression, like you can actually turn dynamic compression on. So all of your service requests comes out, gets compressed, and then on the client side, you'll have to handle that and decompress it. Now, unfortunately, the frameworks on Windows Phone won't actually do that for you. You are responsible for, you'll have to grab a third-party decompression library and actually decompress it yourself. But it is something worth considering if you're downloading data that's particularly highly compressible, like a lot of text data. You can get some quite good savings there, and it will be good for the user's bandwidth. Okay, so this is the case study that we're going to walk through today. Some of you may have seen Capture TechEd, which is a phone app for basically capturing images at TechEd, and then what it does is it takes the image, uploads it to blob storage. There's a worker role there that actually will grab that image, resize it. Now, I could have done this resize work on the client, okay, and actually uploaded a much smaller image, but I wanted to have both the full image and the resized image available in the cloud. that resized image is actually goes to 173 by 173, which coincidentally is the size of the start screen tiles, okay? What we then do with that is that we then broadcast that image to everybody else who's got the app. So it's just a way of, it was actually an example I thought up for this session, but it was a way of demonstrating the power of the cloud and actually how you can use push notifications to communicate those out. So essentially the process we'll go through is capture the image via the phone. That's very straightforward. We're going to go and upload it to blob storage, and I'll talk to you about some issues that we have with dealing with blob storage. We'll actually tag each image with the track for TechEd, and I'll show you how we're going off to a data store and actually pulling that down via a JSON feed. We'll essentially couple the image with the tag. We'll actually then upload it to a queue. Okay, so we'll call it to a WCF data service, WCF service. They'll actually put it onto that image onto queue. Now, at this point, we're not actually dealing with the image as much as we're dealing with the URL of the image, all right? Because we've uploaded the image to the blob storage already. Then once we've processed it, we probably won't get onto showing how to do the pushing out the tiles, but I'll talk through it at a conceptual level how we then do that using a worker role as well. And then we'll go down and actually grab the recent images as well. Okay, so the first part is relatively straightforward. Let's hop in. Just out of interest, how many people have actually done some Windows Phone development? Okay, so a couple of people. Okay, I'll keep this relatively straightforward. Essentially, I'm going to copy some XAML in here. Now, the XAML is basically just the layout of the page, okay? And what we'll see here, and excuse me for a second, I'm just going to add a couple of references in here. So I will grab if you're doing a lot of phone stuff, I'd highly recommend the Windows Phone Toolkit. It's got a number of nice features in it. Okay. Nope, I don't want to do that. Let's try doing that again. Okay, so it found the reference to that, okay. So essentially we've got an image control there. Okay, so we're going to use that to display the image that we're capturing. We've got a couple of buttons here, one to actually do the initial capture, and then we're going to have a separate button to actually push it to the cloud. We've got essentially a list, so this is going to be the ability for us to select a track, and then there's a comment box there as well that we can put a comment in. Let's actually go and wire up some of this logic. So I'll flip over to the code. And I'll scroll down here. Let's get rid of our constructor. We'll come back to that in a minute. And where's my code gone? So we'll create an instance of our camera capture task. So for those familiar with Windows Phone, you'll know that in order to capture something from the camera, back in 7.0, we had to use the camera capture task. Now, in the new version of Windows Phone Mango, we could actually stream the camera feed directly to the UI, and then actually take segments of that if we wanted to. Okay, so there's different ways we can do it in Mango. I'm going to do it a very basic way, just because we're interested in capturing just a still image. Okay, again in the constructor, I'm going to wire up that event, and the event handler looks relatively complicated, but actually all it's doing is taking the stream of data we get back from the camera capture task and decoding it into a JPEG that we're then going to save to disk. Now, the thing about the camera capture task is when it takes an image, it puts that image into sort of like a temporary folder. In order for you to save it for your application and reuse it, you actually need to save it or decode it back into isolated storage. So that's just what I'm doing here. So I'm just taking the stream, which is this chosen photo, decoding it as a JPEG, giving it a name. So I'm just using a GUID as a name, and then writing it to isolated storage. And then we're going to use that to then upload it. Okay, so let's actually just check that runs. Okay, so it's not finding this event handler, because we didn't create that. Let's create that. It's not going to do anything for the time being. Go ahead, capture, and what we should see is the emulation feature for the camera come out. So accept that photo, and it'll actually display it within our application. So that part's all working. Step one, done. So the next part is going to involve actually grabbing a cloud-based project. But before, I just want to talk a little bit about the architecture of uploading things to blob storage. So when you go and register for Windows Azure, you've got the ability to sign up for various services. Okay, so you serve up for some computing time, and then you sign up for some storage. Okay, when you sign up for storage, you're given two keys. You're given a primary key and a secondary key. They're effectively identical. They both give you full read-write access to all of the content in blob storage. Okay. The only reason you're given two is so that you can switch between them. So for example, if you accidentally give people access to your primary key, you can switch over to using your secondary key, and you can actually regenerate your primary key. Okay, so you can gradually transition people from using your primary to secondary key. So it gives you that ability to turn those over periodically if you need to. But the reason that they give you two is because you've given away one of them. Okay, the idea is that you shouldn't give away those keys in the first place. Okay, but if we're not giving away the keys, how are we going to read and write to blob storage? Okay, one option would be that we embed the key within our application. Not a really good idea because applications can be decoded, okay, and you can pull out the key and then you can use that to go nuts on Windows Azure. Now, Azure is pretty clever, actually. There's two types of blobs that you can put up there. You can put public ones and private ones. So public ones, you need the key in order to write them, but anybody can read them. Alternatively, you can actually put private ones up there where you need the key to read and write them. Okay. Now, in our application, it's a very simple application, so we're just going to be writing to a particular part of blob storage. Okay. So we're going to need that key. Okay. Rather than actually giving out that key, the Azure team thought, okay, well, there's got to be a better way of doing this. How about if we generate a temporary key? Okay, that gives, or a policy-based key that gives you certain permissions on an area within blob storage. So that's exactly what this shared access signature is. So for our mobile client, what we're going to do is we're going to go off to a WCF service, and we're going to request temporary access to blob storage. Okay, the WCF service is going to go, okay, well, yep, I'm going to grant you a limited period access. Here's the key that you can use to access that piece of blob storage. Now, what we'll actually return here is not just the shared access signature as a key. We'll actually return the URL that the mobile client's actually going to use to upload. Okay, because the shared key is literally a query line parameter. Okay, so you basically take the URL that you want to upload to, like the blob storage URL, and you append the shared access key on the end of it, and then we use that. We do a HTTP post up to the cloud, to blob storage, okay? Now, the thing about that key, as you'll see in a minute, is that the key is limited as to how long we can use it for, okay? We don't actually have a cloud-based project yet, so let's go ahead and create one. So add new project, okay? You'll see here that there's a new cloud entry here. Now, there are a couple of different SDKs that we use here. So obviously, we've got the Windows Phone toolkits installed, okay? So we've gone to create.msdn.com, download the Windows Phone SDK, okay, install that. The other one is the Windows Azure SDK, okay? So you need to download and install that, otherwise you won't get those cloud-based projects. And later in the slide deck, you'll see that there's a reference to the Windows Azure Toolkit for Windows Phone or iOS or Android, right? That's a separate SDK, okay? So you need, and if you're going to go down that path, you need all three of those SDKs. And you'll see that these two bottom projects are part of that latter SDK. So, but in this one, we're just going to create a normal Windows Azure project. It isn't a single project. What it is basically the Windows Azure project is essentially the deployment project, and then you have projects that are associated with this. So, and it gives you a whole bunch of templates that you can choose from. We're going to pick a WCF service template, and we're going to pick a worker role template, okay? So grab one of those, and you'll see that it's added 3 projects. So this Windows Azure project is essentially our deployment or our packaging project, okay? And that's the one which you actually use to deploy things and set up the configuration for your services. We've then got a web role, okay, and you can see that there's a service one there that we probably won't use today. And then worker role, we've actually got a worker role project and associated class in it. Now, what I'm going to do is jump into and set up the configuration for these first, okay? So one of the things we're going to need in here is the ability to add remembering this is working on the server side in the cloud, okay, so we're going to add our primary key, or the access key, for blob storage so it's available to our application. Now, because I'm going to be running on the development storage, I'm actually going to just use the development storage key. So data connection string, it's literally just a connection string that you'll see in a minute. And we've got a dialog here that basically says either use the storage emulator, which we're going to use in this example, or enter your storage credentials. Okay, so if you're going to be connecting to Windows Azure storage, you'll need to put your account name and key into there, and then it will get packaged along with the configuration file for your Windows Azure project when it goes into the cloud. Okay. Note, we're not pushing out that key to the client. It's all based in the cloud. Okay. So time being, we're going to use storage emulator. And we're going to have to do the same configuration. So that was for the web role. We'll do the same configuration for our worker role. Sorry, I'll leave that as that. Just need to do that just to get the use development storage equals true there. Save that. Okay, let's go and write some code. So the first thing we're going to do is actually I'm going to create a new WCF service in here. So add new WCF service, and you'll see that this is very similar to just creating a new one as if it was just an ASP.NET project. So image services. And it'll give us our interface file and our service definition. Okay, so I'll come in here, and we're actually going to replace this with some code that I've got here. Okay, I'll let Sharper do its thing. Okay. Now, one of the things you'll notice is that we've already got, as part of creating those projects, it's already added references to the major cloud assemblies in there. So these are basically managed wrappers over HTTP operations. So the majority of the operations, in fact, all of the operations against blob storage are HTTP operations. So the HTTP put, post, get, and delete. Okay, so those are the basic operations for dealing with blob storage. Now, obviously writing HTTP web requests for doing all of that stuff is a real pain if you have to do it every single time. So the team said, okay, we're going to make it really easy for .NET developers. We're going to provide a set of managed libraries that encapsulate all of that. So that's what these 3 libraries are for. Okay, and the nice thing about them is they give us code that we can then work with. Okay, so that's all I've done in here. Let me just add the configuration, the service definition in here. And then I'll walk through what the code does. Okay, let me just check that it builds. All right, let me just walk through this code so you know what's going on. So we're initializing storage. So essentially this initialized storage is going to be called just to set things up. So the first section here, you'll see that it goes off and establishes just some of the base configurations settings for the role. Okay, so that's basically saying, okay, every time the configuration changes, go and reload the configuration and actually pre-populate the application. Okay, so that's important because once we publish our cloud into our project into the cloud, we can actually go into the cloud, like the Windows Azure management tool, and actually change the configuration on the fly. Okay, so we can increase the number of instances, or we can change some of the configuration to point to a different set of blob storage or a different SQL backend on the fly. Okay, so it takes a little bit of time to propagate, but essentially that's what that first little bit actually establishes and makes sure that our application is set up to do. The next part is that we're actually going to use that data connection string that I just set up, and we're actually going to grab that configuration information, and we're going to create a Cloud Blob client. Okay, so that Cloud Blob client is what we're going to be using to interact with the blob storage. Okay, all of that's well and good, but let's actually do some stuff with it. So this get container shared access signature method, which is the method that we're actually going to be exposing as our service call, is going to use that cloud client, the blob client. Go ahead and make sure that that container exists. Okay, so that's the first thing we're going to do. And then there's a method called get shared access signature, and as part of that, we're setting the permissions on there. So we're setting, this is a constant, so F12 on that, and you can actually see that all we're saying is we're going to give it write permissions, delete permissions, and list permissions. Okay, so I'm going to be able to do all of those operations, and of course, reading is implied in that. Okay, so those are the permissions I'm going to be granting. Okay, and we're going to set the shared access expiry time to UTC now plus 5 minutes. Okay, so we're essentially giving it a 5-minute window in which we can interact with that blob storage. Okay. The last thing we're going to do is actually provide back the path to the blob that we're going to be accessing. In fact, this is actually a container URL. Okay, so it's actually, you can think of it as a folder. Okay, so this is going to be the folder that we're going to write to. On the client actually will actually say, okay, well, here's the name of the file, and it'll actually append that to the path. Okay, and then the other thing that's on this URL is the shared access signature. Okay, so we're setting that to the shared access signature, and we're just trimming off the question mark prefix on there as well. Okay, so the return thing is actually the URL that we're going to be posting to. Let's actually, we'll actually browse to that service just to make sure it's all set up properly. Okay, because then once we've done that, we can go into our phone project and go add service reference. Discover, it's found our services, image services, like that, and it's basically added it to our application, okay? Now, the one thing to be aware of there is that when we actually browse to this particular service, what we saw was actually the standard ASP.NET site running in Cassini. So you can see here localhost and then the port number, okay? So it's running in the local instance here. It's not running on ISS, and it's definitely not running in the local cloud emulation, like the compute storage, simulator, okay? So what we need to actually do is actually change the configuration in here to actually point to the simulation for the cloud environment, okay? So what we'll actually do is come down here and actually just run this, okay? And actually you'll see that it comes up and it actually runs up on a different port number. And you'll see down here that the emulation started. So we've got both the compute emulation and storage emulation, okay? And those are priming up now. So that was Cassini. Okay, so now we can see a different port number. Okay. Now the interesting thing about this is even though we're accessing it on port 81, in theory, what it's going to do is it's going to reroute that to one of multiple machines. Now the machines that they typically get allocated on the development environment start with port 50,000, and they go 50,000, 50,000.1, and stuff like that. Okay. But the important thing is when we're communicating from our phone application, we're going to be going to port 81. Okay. So let me just grab that URL, come back to our phone project, and we'll actually stop this running. Drop that, stop that. Come back up to our phone project and just go to the configuration file in here and just change the base URL address in here so that it points to the right number. Okay, so that's now pointing to the cloud, so it's going to communicate with the cloud. Let's go back to our phone application and go to our main page, because of course we now need to call that. And we'll grab some code from over here. So we're going to call that. So this is the method that's actually going to call that. So we'll add the references to that. So after we come back from capturing the camera, we're going to go and retrieve the upload signature. Okay, so this is the method that we've added in here. And all we're doing is creating an instance of the client class, okay, attaching the event handlers, and then we're actually calling it, passing in the name of the file that we're going to be uploading, okay? And when we get back, what we'll get back is the URL that we're going to be uploading to. Okay, that makes sense? Coupled with our shared access signature. Once we've got that, the next step along the way is that we actually need to upload it to the cloud. Now, rather than me writing a whole bunch of code to actually do that, there is actually a class that's part of the Azure Toolkit for Windows Phone that actually will do all of the uploading to blob storage. Now, there isn't an official SDK library for doing Windows Phone to the cloud. The Azure Toolkit is pretty close as you can get. So I've actually stolen this library straight from there. Sorry, stolen's not the right word, borrowed. Okay, so essentially, this essentially does the same wrapping as the storage client library on the desktop or in the cloud. So just add some references in here. Okay, so there's a chunk of code there. Now this is, the interesting thing here is it's not as simple as just doing a HTTP post to a particular URL, okay? That would work if we're dealing with perhaps a 1K size file. We're not, we're dealing with a photo, okay? So the issue here is that if we post that all as one chunk, the likelihood is we'll go into a tunnel and halfway through doing it and it won't make it, okay? So the nice thing about this code is that it actually partitions it into a bunch of blocks, uploads each block individually into the cloud, and then it tells the cloud that these blocks are one file. Okay, so the cloud then knows about that and it will package it together. Okay, so that's the purpose of this cloud uploader. Okay, what we're going to do is then actually make use of that in our code, and we'll copy that into here. Okay, so this is my upload image code, and you'll see here that essentially what we're doing is we're grabbing the upload URL that we just got back with the shared access signature. We're going to append the file name to it. Okay. We're going to open isolated storage because that's where we're going to be reading the file. Remember, we saved the image to isolated storage, so we're going to open that for reading. We're going to pass that stream into the cloud blob uploader along with the URL that we want to write it to. And eventually, after a certain period of time, we'll get a message box back saying the upload complete. Okay, and then we'll kick off it. And of course, we need to actually wire that up to the event handler. So let's actually do that. All right. So let's actually run that up. could be waiting a long time, given it's not going to run my phone project up as well. When you add the cloud project, it sets the cloud project as the default one, so it's wired that up, and then forgets about loading the phone project. So we'll go ahead and capture the image. Capture that, comes back with the image, and sure enough, it's gone off to the cloud service, and it's got back quite a long URL. So you can see here that that's the URL that we're going to be uploading to. And this part right at the very end here, actually it goes on probably out to about here, is that shared access signature that basically gives us read-write permissions to that particular URL. If I didn't have that, I wouldn't be able to write to that URL. Okay? So that's given us our URL. Now when I hit the upload button, it says upload complete. Okay, so basically it really quickly went through that. Now, don't get confused. Firstly, I'm running on the Windows Phone emulator, so it's significantly quicker than an actual device. Firstly, I'm running secondly, I'm running the cloud storage emulation on my machine. Okay, so the connectivity between the phone, or the emulator, and the development storage is going to be super quick as well. So that photo actually, if I did a comparable thing, if you download the app of Marketplace for Capture Tech Ed, it actually takes about a minute or two to upload the photo. Brian's shaking his head. It's longer, isn't it?
Sometimes.
Yeah. Yeah. So it's much quicker if you're on the Wi-Fi network, or even if you plug it into your machine, but it's really slow over the 3G network, particularly when you've got so many people with phones in the same location. Hence the earlier slides about network congestion. Right, so we've done the first step. Let's actually go back to our slides and look at what's next. Okay, so we've got the blob in the sky. The next thing we want to do is we want to go out to the TechEd OData store. Actually, we're not going to use the TechEd OData store. We're actually using there's an event point API that gives us back a JSON object. The reason being is that when I was doing this demo and doing it for New Zealand, they didn't expose the OData feed for their TechEd. Okay, so it would have been a really nice OData feed for Australia, but I haven't changed the demo since New Zealand because EventPoint's got both New Zealand and Australia data on their API. Okay, so we're going to use that to pull back the list of tracks, okay, and we'll expose that as a drop-down list so that we can select which track we want. And then once we've done that, when we upload, okay, we're obviously going to be doing the upload to the blob storage, but we'll also upload the job into the cloud as well. Okay, so that's the next step in the operation. So we'll come back into our code. We'll whiz down here. And grab the download tracks part. Okay, so we're actually going to go ahead and download the tracks basically as soon as the application loads, because we're not going to wait for them to take the photo and then download tracks. That doesn't make much sense, given that they then have to wait for that as well. Okay, so we're connecting to the EventPoint API, okay, and in actual fact, it's verbatim in the code with their API key, just for simplicity for the demo. I would not recommend that you do that. No API keys in your applications, thank you very much. And essentially, once we get a response back from them, we're going to decode it using the data contract JSON serializer. There are better technologies out there than the data contract serializer. If you're going to use a lot of JSON, then I'd recommend JSON.NET. It's more performant and gives you more flexibility in the way that you decode things in fewer lines of code. But this one's really good because I don't have to reference an extra library. The other thing you'll notice here is that we've actually includes a data class, and this data class is just what we're going to be decoding the JSON to. Okay, so it's got a track ID and a track name. So when this actually invokes, it'll actually set the data source for our item picker, so we can actually pick the tracks. Okay, so that it'll decode it and set the item source. Okay, we've got this dispatcher in here as well because when we go off and do the download, we're doing that on a background thread. Okay, the data comes back, we're still on a background thread. If we go and update the UI or the user interface from that background thread, we'll get an exception being raised. Okay, so it's important that we make that jump back onto the UI thread. Okay. The next step is going to be to actually connect to the service in the cloud. So of course we're going to have to go and create that because at the moment we don't have both of those services in the cloud. So let's jump back over here and we're going to go to the interface file first. Nope. Let me try that again. We'll actually do the code in here first. Sorry. So the first thing we need to modify in here is actually up in isolated storage. Okay, so far not isolated storage, in the initialized storage method. At the moment we've initialized the blob and the blob client so we can connect to that. We haven't actually initialized a queue. Okay, so this queue that we're going to add into here is going to be used for connecting, for storing our inbound items so that the worker roles can process it. So we'll go ahead and create that. Okay, so that's going to give us our reference to our queue. Okay, so we'll do that as part of the initialized storage method, and then we're going to actually create the method to actually work with that queue. Okay, so come down here, and we'll grab the new image capture. Okay, so it's very simple. We're passing in the comment that the user's making, the track name, and the image URL. Okay, so the URL of the image that we've uploaded already. Okay, and actually all we're doing is, we're not doing anything particularly fancy here. All we're doing is condensing those into a single string and adding that as a message into the queue. Okay, you can do whatever serialization logic you'd like to actually put stuff in the queue. Just bear in mind that there is a limit to how big the queue item can be. I think it's about 2K. Okay, so you can serialize whole objects into there if you want, like just using a normal JSON serializer or data method. But at the end of the day, it's got to be, the format that you put in the queue has got to match between both the web role, which is inserting things into the queue, and the worker role, which is taking things off. Okay, so I'm going to go for a very basic one, which just adds a pipe delimited comment in there. Okay, the other thing we need to do is obviously go back to our interface and grab the definition for that. Okay, so that's our server side done. Okay, and we'll run that up just so that I can actually update my code for the phone project. Okay, once we've started that running, we can just exit that. And in theory, when I update this, it should go away to the cloud and actually update that. So when I come back to my main page in here, I'll come down here, and we're going to write some code to actually queue that. Okay, so again, this logic is relatively straightforward. All we're doing is creating a new instance of the client, attaching an event handler, and passing in the comment text, the selected track, and the blob URL. Okay. The other thing we've done up here, though, is actually we've trimmed off the query parameters. Because remember, when we went off to get the shared access signature, we appended the shared access signature as a query parameter. We don't want to pass that off to the cloud because the cloud already knows how to connect to it. It already has those keys, so it doesn't need the shared access signature. So we'll actually trim that before we send the URL off to the cloud. Okay. We just need to write a little bit of code up here to actually call this method. So up here, once we've actually, that's the picking of the track. Let's actually come up here. Nope, that's not right either. So new image capture. Upload click. We're going to wait until we've uploaded the image. This is the part that I was looking for. So we uploaded it successfully. Okay, so that's adding it to the blob storage. Okay, so what we then want to do is actually queue it. Okay, so and we're going to pass in the blob URL into that. Okay, so that's going to queue it and call that to the service and actually queue that. So just get 12 on that. And once that's queued, we should get a message back saying that it's been successfully added to the queue. Now, the one part I didn't add in is that the call off to main page loaded, we actually need to wire up that event handler to the loaded event for the page. So I'll just come up here to the constructor. Okay, and wire that up. And run up our whole project. Okay, while we're waiting for that to come up, we'll just come over and actually start the phone project as well. Okay, so you can see here that it's pulled back those lists of tracks. Okay, so it's decoded those okay. We can go off and actually capture an image from the camera. Okay, and it's brought back our shared access signature. I'm going to add a very quick comment. And before I click the upload button, I'm going to come over here to our cloud-based project, delve into our not into WebRoll, our image services, and down here where we're actually capturing this, I'm actually going to just put a breakpoint in here so that when I click the upload, what we should see is that it's uploaded it, so that's the upload to blob storage, and then it's actually sending the message to queue it. Okay, so our queue message is very basic. It's got the image URL, and then you can see just on the very end here, there's a pipe, and then we've got the Windows Phone track, and then that'll be followed by the comment. Okay, so it's a very simple message. Okay, so that message is now in the queue, and we've added actually the content to blob storage. Of course, we've now got to flip over and actually do the worker role side of things. Okay, so let's just do a recap on that. So on the back end of our WCF web role, we've got the ability to queue, and then once we've queued it, this is when our worker role kicks in. And the worker role does a couple of things. So the first thing it does is it picks up those jobs off the queue. Okay? It then goes off to blob storage and actually gets the image that we've uploaded. And it's actually going to resize those. And then it's going to put the information about that blob into SQL Azure. Now, the thing about SQL Azure, as I mentioned before, is it ends up being the sticking point or the slowest point in the whole operation. But the nice thing here is that the only points of contact to SQL Azure are going to be our worker roles. Okay? And we'll see later that when we're going to send the notifications out again, we actually use the worker role to basically do that and send the notifications out as well. Okay? So rather than a front end having to touch SQL Azure. Okay, so let's actually write the code to do that worker role. So we'll come down to our worker role project down here. And you'll notice that the worker role project or class is very simple. It's got an onStart, which gets invoked when it's starting up, and that's your opportunity to write configuration stuff. So basically, okay, which storage client am I going to be accessing and those types of things. And then it's a run method, and the run method is a while loop. Okay, so while true, keep running. Okay, it's very, very straightforward. Now I'm actually going to cut out the original code here and drop in a bit of code of my own. So the first thing we're going to do is have the onStart method, okay? And you'll see again, we're setting up things like the Cloud Blob client. Okay, remembering these are distinct projects. So we've got our web project, okay, and we've got our worker role project. So we're going to do the same thing for both of them because we want to be accessing the same blob storage and the same queue, okay? So you'll see this code is very similar, okay? So again, we're using the data connection string that we set up, okay? We're using queue with the same name, and we're setting up a storage client so we can access blob storage, okay? I won't define those variables because it's in this snippet of code already. This loop here, okay, so we're going to be connecting to the queue storage. Now, one of the problems with queue storage is you get charged per transaction, okay? So if you're continually hammering the queue, you'll end up racking up quite a bill, okay? It'll also mean that, you know, yes, you basically don't do that. And there's no point because, you know, if the queue's full, then it's great. You continually get stuff off the queue. If the queue's empty, you may as well just sit there for a little bit, okay? And what we're doing here is actually starting off with a default sleep period, and the default sleep period I think is 10 seconds. And we've got a sleep increment of 5 seconds. So if there's nothing in the queue, we actually extend our sleep period by 5 seconds, 5 seconds, 5 seconds, until we get to 60 seconds. These are arbitrary constants. You can change them to suit your particular scenario, okay? But the point is that we're not completely thrashing that queue, so racking up a huge bill, okay? And all you do is max out the CPU on the instance that you've got running. Okay, what we do is we query for the message. When we do get a message, we're actually going to decode that, and the decoding is pretty simple. We're just doing a string.split, okay? But if you're encoding a whole object, you want to make sure that you deserialize that properly, okay? And then we're going to pull off the various components. So we're pulling off the image URL, the track name, the comment. And then we're doing two things. We're going to resize the blob, okay? So we're going to go and grab the blob, resize it, and put it back, in this case, in exactly the same position, okay? And then we're actually going to save the contents of that blob to the database, okay? So I'll go and grab those methods as well. Okay, so I'll come down here, and we're going to resize, okay? And so you notice here, we're basically just doing some drawing operations. So let me just add in a reference to system.drawing. Okay, so then we can just accept all those references, which is good. Okay, so you can see here that all we're doing is actually, there's just a little bit of logic there that just does a resizing and a bit of a cropping, okay? The next part is to save the contents to the database, okay, and we'll put that into there as well. And you notice here that we're just using Entity Framework, okay. We need an entity model, pretty easy. In our worker role, all we do is go add new item, okay, data, ADO.entity model, and we're going to call this cap data. And I've already got the connection string set up here. Now bear in mind, I'm putting here the local connection string to MySQL Express. It's just for development purposes. You can replace that when you go to the cloud. The process I normally follow for doing that is that when you're getting ready to launch to the cloud, the first thing you do is you change this from being a local instance SQL Express to being SQL Azure in the cloud. You can run everything else locally, development storage for blob storage. You can run your processes locally and just connect to SQL Azure. The next step is then you connect to blob storage in the cloud. Okay, so you've now got SQL Azure, blob storage in the cloud, but your compute is still locally. And finally, once you're ready to go, you hit the publish button, and obviously you push everything to the cloud. Okay, and then it just runs, ideally. The nice thing about this is that at least you can iterate relatively quickly, because that publishing process takes about 5 minutes. Okay, somewhere between 5 and 10 minutes. As a contrast to publishing the Windows Phone part of your project, which takes probably 3 to 4 days, if you're lucky. Okay. No, my application got published in 3 to 4 days. It depends on how complex your project is, of course. I have seen other projects take longer. Okay, we'll come in here and finish off this. Okay, so that's our entity model, and you'll see that hopefully I rename things properly, and we're going to assign this to Australia. Okay, so our code will now hopefully compile. There's one more reference in there that I didn't get. Okay, so we've now resized and uploaded that component to the cloud. Okay, and I'm just going to put a bit of a breakpoint just in here. Okay, and we'll run that whole thing up. And we'll just come back up here while it's running, and hopefully I'm in time to get. All right, so it's picked up that one message that we'd already queued. Okay, so I haven't done anything on the phone side. This is just the message that we'd previously uploaded into the queue, because remember, development storage is still there, the items are still in the queue, because the queue, it's not like a transient queue, it's actually a persistent queue as well, which means that it's in the cloud, and it will retain those messages even if various nodes in the cloud disappear. Okay, so it is a form of storage, albeit in most cases it's relatively temporary. Okay, so we're going through and get that image. Okay, we'll resize it. Okay, so you can see the image URL here. Okay, and I'll just make a note that it starts with 1.6 because we're going to load up Cloudberry Explorer. This is a great tool for both development storage and also when you finally publish your app. And we'll drill into that particular image and open it. And you can actually see that it's the image that we initially uploaded. And you'll notice down here it is 173 by 173. So it has been resized in the cloud, which is what we expect. And so coming back to our project, I'm going to go ahead and finish saving it to the database. And you'll see that that all flows through and adds the record for us. Okay, so the next thing that we're going to need is the ability to expose that information out. Okay, because great, we've got a backend data source. What we're going to do is actually expose that using a WCF data service or OData feed. Okay, so we're going to come to our web role. Again, I'm just going to do add new item. Okay, come down here, WCF data service, captures data. Okay, and now this WCF data service is going, I need an entity framework model or an entities model to work with. Okay, so again, I've got to go through that same process with my web role. Okay, add new item, data. And we'll go through the same process. Now, if you're doing this for a real application, I would highly recommend that you share these between them. So you create an additional class library and actually share these, like the entity framework model between those two. Because it means that if you update it in one spot, it flows through and updates it in the other one. And you'd want to do that for things like queue names to make sure that they're consistent between your web role and your worker role. And for similar, for things, for methods for decoding and serializing objects that you're going to be passing through the queue, again, have that logic in a shared resource that you can access from both of them. So that's our entity framework model, and we'll just come to here and actually tell it to use it. Okay, and then the last thing we need to do is actually, so that will set up our OData feed with nothing in it. What we just need to do is actually tell it which of the entities we're actually going to make use of. So we'll drag that in here, and you'll see here what I'm setting up two things. I'm basically saying I'm going to expose all of the sets of data in my entity model. Okay, in this case there is only one, so it's the captures table. Okay, but I'm also going to limit the page size. Okay, I'm going to say, okay, only bring back 20 items at a time. That's a big thing, particularly if you're exposing to mobile clients, because otherwise the mobile client will go, give me every entity in this set. And then the user sits there and goes, okay, I'm waiting because I'm waiting for 1,000 records to come down. It's okay if you've got on a high data connection, because those 1,000 records probably come down like that. On a mobile device, it's going to be quite painful. If you bring back a limited page set, not only are you saving resources on the server side, you're also having a much more engaging experience on the phone. The nice thing about the OData feed is that there is a link at the end of it, which basically says, here's my next 20. Okay, so you can call that link, download the next 20, download the next 20. Okay, so you can get that progressive interface of pulling back more and more records, okay, which is much better than having the user holding on and waiting. So let me just run this up. That's all we need for the OData feed. And I'll flip over, let's just close this down. Okay, so capture. Oh, there we go. So you see that this is basically the head feed. Okay, so it's basically listing all of the entities sets that I've got there. And if I go captures on there, you'll see that it actually brings back my list of captured items. Okay, so these are the items that are actually in the SQL Azure database. Okay, if you're going to be querying this on a very frequent basis or exposing this to the client, you would want to think about how you're going to cache it, because remember what I said about SQL Azure. Don't connect directly to it. Okay, it is a very convenient way of exposing that data in a very rapid fashion, but just think about the usability scenarios of actually connecting your mobile application directly to this. Now, I'll come back to the slides and we'll just actually talk through the remaining scenarios for this architecture. Okay, so the next thing we wanted to do is actually just send, now that we've resized those images, we actually want to send out a notification to all of the mobile users that are using this application. Okay, so essentially we do this process again. So we basically say, okay, well here's the tile that I want to send out as an update. I'm going to put that onto the queue, okay? Worker role basically picks that up and says, okay, well I know I need to send this notification out. Who do I need to send it to? And it goes, okay, well here I've got a database of registered users or registered devices. It goes and adds every single one of those as a record into another queue and basically says, this queue has basically got a list of messages going to a particular phone, okay? You then have another worker role, or it could be the same worker role picking up off different queues, that basically picks up each one of those and sends out that notification. Okay, so now you've got scalability at multiple different points through the use of queues. Okay, so and at no one point of there are you going to get a bottleneck that you can't change or get rid of by increasing the number of worker roles. Okay, this is particularly relevant because if you've got a lot of mobile applications and you're going to be using tile and toast notifications, the problem with the Microsoft services is that they don't provide you a mechanism for doing a bulk send. Okay, so if you've got 10,000 users or using your application, you're going to have to do a HTTP post to every single one of those endpoints, okay, which is a real pain if you've got the same message to send to every single one of those. Okay, so actually using Azure to actually do that means that you can basically iterate over those relatively rapidly, and if you're sending a high volume of those, you could actually spin up several instances of Azure or the worker role and do all of those in split second, as distinct from it taking half an hour to send all of those messages, perhaps, okay, depending on how many users you've got. Now, I've actually used this model. I've actually got essentially a framework in the cloud that I use for notifications across multiple applications. So rather than me having to write the same logic over and over again, I've got quite a good level of reuse, because every time I've got a new phone application that I want to make use of notifications, I basically go into that service and say, okay, I'll set up a new application, and it basically will automatically register every single user of the application. So it's do it once, think about how you can then scale it and actually reuse those services. Because Azure can actually get relatively expensive if you're having to pay for a worker role and a web role just to do notifications for every single application that you're thinking of building. Okay, the last part of that is, as we saw, was the pulling back from OData. Okay, so we end up with an architecture that looks a bit like this, pig's breakfast. Okay, but the thing about it is that we've gone from being a very elegant design that's slow, okay, because we've got SQL Azure front set of services and a phone connecting directly to our database, not good, to one that looks like a pig's breakfast because we've got things going all over the place, but it's actually quite performant from the usability perspective. Okay, I just want to touch on the Windows Azure Toolkit for Windows Phone. I didn't want to go through an example of this because there is a lot of content in there, and it's a matter of, okay, well, where do I start? And I figured it was actually better to go through that worked example of how you connect to things like worker roles and why you do certain things with blob storage. I would recommend that you do grab the Windows Azure Toolkit because it does demonstrate a couple of important things. Actually, that first line's also changed. They've got the membership providers for both table storage, and they've also got a membership provider for SQL Azure. They've also got a membership provider for ACS. Okay, so ACS is basically a way that you can aggregate users from Facebook, Twitter, other social networks, and get them to use that form of authentication to authenticate to your set of back-end services. So that can be quite useful. It does have examples of how you do push notifications and how your how your phones can actually register for notifications. Because it does have both parts. It's got the back-end services as well as a phone app that you can walk through the code of. And it shows, again, how you connect to table, blob, and queue storage. Okay, so I would recommend it. They've just released the Android version of it as well. So this team is particularly active and always willing to take feedback on the direction of it. Okay. I'll leave you guys with that, and thank you very much for attending the session this morning. I am always available. My blog and email weren't up there before, but builttoroam.com, feel free to email me. I'm more than happy to take questions. Thanks, guys. Questions? Or were you stunned still from last night? Yeah. It's not blocking, no. It'll return something pretty much straight away. Now, there are methods there that you can call to query how many items there are in the queue, but it's not a definitive because and I think that the method actually has that in it, like it's an approximate message count. The reason being is because it's an eventual consistent state. So at any one time when they take that reading, they'll say, okay, well, there's no items in the queue, but somebody might have been putting items onto the queue. So you can't take that verbatim. That is probably, that you can use that to optimize the sleeping pattern. And quite often I'll do that. So I'll query that and then sleep for a very short period of time and then query that again. And then if that grows over time, then I'll use that to actually throttle down and things like that. Anyone else? Yep.
Is there a pricing model? You said every time you preview, you call them up and check if the queue is empty or not, you get charged?
My understanding is yes. When you query the queue, you get charged for that transaction. Yes. I think I'm not sure about when you query the count on the queue. I'm not sure about that. I know that it's very unclear when you look at the blogs as to what you get charged for and what you don't. So. Yep.
You don't, if you like, let's say at a time job, which is once every hour, and one time, once an hour.
Yep.
You don't have to put a thread or sleep in there for an hour, or you should.
You probably should. Yeah. So I've got a worker role that's up in the cloud that polls off to the Bureau of Meteorology and does readings off the various media states there. And actually uses some logic to for each one of the nodes that the weather department's got. It actually the frequency varies depending on the different nodes, and so it might be anywhere from half an hour to 4 or 5 hours. So for the 4 or 5 hours ones, yeah, I sleep for 4 to 5 hours, and then I actually work out which one's the next one to go or be updated, and then I sleep for that amount of time. So, yep. rather than putting all of those into a queue for a certain period of time, just polling them. Are we all going to go and build phone plus cloud projects? Yeah, cool. Are we already building for the cloud, or is it just general interest stuff for Azure? Bit of both, yeah. Yeah, so that Capture TechEd, the first cut of that, I built in sub 12 hours. So, and published to the cloud and had it working on my machine. And actually, I did go through the submission process for the Windows Phone Marketplace in that 12 hours too. But obviously didn't get published in the 12 hours. But yeah, no, and to me, that was a proof of, okay, I've got an idea that I just want to try, okay? Boom, 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 it's done, it's out there. It's actually running on production hardware within the 12 hours. Like, didn't have to provision anything, you know, I scaled it up to 1,000 boxes, woohoo, you know. If I get slammed overnight, then, you know, we can scale. And to me, that's the pure value of the cloud. That ability to scale dynamically is, you know, is awesome. So.
What's your recommendation when you have an app that needs the data offline? So not just images, more like a contact. So you save into a SQL.
Okay, so that example where I was doing the weather. Okay, so I'm still using blob storage. Even though it changes every half an hour, what I do is I go out to the station, grab the latest data, and I actually pre-can a JSON object, put that into blob storage, and I set the cache period on there so that it matches how frequently the data changes. And so the nice thing about that is not only is it available in blob storage, so I can pull it straight from there, it's available on the CDN, which means that if I'm in Australia, I don't have to rely on it coming all the way from the US. My phone just goes straight to it. You know, it becomes really, really quick. The only downside is that you can't do stuff that's going to change instantaneously. So if you're doing stock market data, you need it to be down to the second, then that's not going to do it. And you know, you need to think about probably connecting to some sort of scalable back end. But the issue there is that as soon as you're talking about scalability and instant availability of the data, the two just don't go hand in hand. I mean, so you've got to start thinking about, okay, I want it to be consistent eventually, okay? So they talk about eventual consistency of data storage. And if you look on Facebook and Twitter and all those major sites, they do this eventual consistency, okay? So at any one time, if I go and update my profile on Facebook, if I go to access it in, say, the UK, I will get my old contact info, I'll get my old data from Facebook for probably up to 12 hours because they do eventual consistency. So they basically, the changes propagate from here, my local cell, where I'm going to be using it quite frequently. They do that almost instantaneously. But then they make the assumption that if I'm not going to teleport to the other end of the world overnight or instantaneously, right? So they can propagate that all the way through eventually. Okay, so it's a matter of knowing your data and knowing how frequently and what parts of it needs to be updated immediately. Yep.
Obviously, you've spoken about a lot of it, getting your data off, Azure and everything else. Do you also store a lot of your data then that you've captured into isolated storage and stuff, so that if I put up your application again and I wasn't able to enter all the...
In Capture TechEd, I don't, but yeah, I would. Actually, no, it does for the list of session tracks, but it doesn't for anything else because it was a very basic app. But yeah, that's what I do normally. And again, it's about knowing your data, knowing how frequently the data changes, how often you'll need to refresh it or change it. Like the tracks for TechEd, okay, they were baked months ago. They haven't changed, okay? So I only need to get them once. In fact, I don't even bother checking for updates, ever. Because I just rely on the fact that they're not going to change. Actually, no, I tell a lie. If you go in and you can toggle between TechEd New Zealand and TechEd Australia, if you do that toggle, it will go and flush out the data. But other than that, it won't. So.
Another thing also is storing data that is easy, accessible,
Yeah.
and infrequently opt-in.
Yeah.
CDN is, I think,
Yeah.
So any frameworks that make it easy to synchronize between
No. It's a bane of our existence. Hey, sorry?
Synchronizing now has any problems, replication.
No, that's right. Yes, I mean, we've got merge replication. No, sorry, fail. Oh, we've got sync framework. No, fail. Sorry, that doesn't work on Windows Phone either. It's just like, thanks. And, so They did have a Sync Framework v4 that they were working on, which had providers for iOS, Android, web, like as in HTML, JS, and they were working on Windows Phone. But then a couple of things happened. Firstly, the team got yanked for some reason, and secondly, Windows Phone now has SQL Compact, so they were thinking, oh, well, now how do we do that? And of course, whilst we've got SQL Compact, we don't have change tracking within SQL Compact. Well, we don't have a managed API for doing change tracking, right? So all of a sudden they've got to go, oh, okay, well, that's the problem, because if we start exposing the change tracking, then all of a sudden we're breaking down this lovely link to SQL model that we've currently got. But we can't do it without it, right? Now, actually, you can hack SQL Compact to actually enable change tracking. You basically create the database on the client side, on the server side, or your desktop side, enable change tracking on it, and that's actually done at the engine level, rather than at the managed APIs for accessing the content. So once you've enabled change tracking, then it's change tracking on for the tables that you've got, right? So you can actually query that data on the client. So there's a blog post I've got for doing that if you're interested. So yes, you can use change tracking within SQL Compact, and then you can write your own layer. Because the nice thing about that is it will detect when things have changed in versions in the database, so you don't actually need to keep a manual record, like you don't need to duplicate objects and work out whether things have changed or not. So it does that level for you, but you're still responsible for doing the synchronization to the cloud. If you look at, again on my blog, I do talk about synchronization with OData and how you can do that. There's a relatively simple thing that you can add on the server side in terms of your entity framework model that will basically means that it will track when items are updated, and rather than deleting objects, it will automatically force them to have a flag called isDeleted. So that can be quite cute there. And then I've got some client-side code that will allow you to do basic change tracking for that stuff. Unfortunately, it's not something that Microsoft have actually given us a solution for yet. They never end up getting Sync to work properly. Like they've got several departments in Microsoft that actually work on Sync. So Live Mesh, Groove had a method for doing synchronization. Obviously, Outlook's got a method for doing synchronization. So there's different repositories of knowledge throughout Microsoft that know how to do Sync, and some of them actually very well. Like the merge replication team, awesome. Like if you've ever got merge replication to work. You need a rocket science degree to do it, and you actually get a certificate for doing it. No, you don't really. But it actually works really well, right? And it worked really well for Windows Mobile, desktop, the whole works. And then they said, oh, well, nobody's using that. It's like, yeah, that's because it's too hard to set up and too hard to manage, right? But it actually works really well. We had, on mobile devices, we had it syncing somewhere in the order of 800 megs worth of data. So quite significant data sets. All right, thanks very much, guys. I'll be hanging around. I'm more than happy to take offline questions as well. So thanks, guys. Oh, don't forget to fill in your evals if you love the session.